So we're going to have a look at this lab 3.2.1.6, which is the Internet Meter Visualization lab. And the first thing we're going to do with this lab is we're going to clean and analyze the data of the Internet Meter lab. So with this lab, what we're going to do is we're first of all going to grab the data, we're going to clean it up, and we're going to look at how we can visualize it in different ways. So we're going to be using matplotlib in a number of different ways. But first of all, we need to clean the data, get it into the format we need. So prep it before we can do our visualization. So it's interesting here, they're saying in the lab that sometimes data analysts or machine learning practitioners spend 80% of their time cleaning up the data. So some of the things that, obviously you need decent data before you can do any reasonable analysis. And then, possibly if you want to move on from that, you can use it for machine learning. But there's an old law, garbage in, garbage out. So what that means is if your data is pretty ratty, it's full of garbage, then you're not going to get many insights out of it. Or if you want to use machine learning, you're not going to be able to train a model on dodgy data. So cleaning the data is really important. So in clean and analyze, the first step is to clean it up, and the data that we're using is in RPI data compact.csv, and this contains measurements of internet speed acquired during that internet speed data acquisition lab that we did earlier in chapter 2. So we've got three quantities. We've got the ping time, which is in milliseconds. We've got the download speed, which is in megabits per second, and the upload speed, which is in megabits per second. So if we go and have a look at that data here, RPI data compact.csv, we can load it into a Pandas DataFrame called df_compact. So let's do that. Let's run this. Let's import Pandas and NumPy, and we'll go and grab that data and have a look at it. So we can run this and do a df head, a df compact head, and just look at the first three lines. And you can see here, so we've got, this is our index 0, 1, 2. We've also got another column here, which looks like it just mirrors the index. So that's probably pretty redundant. We probably need to get rid of that. Then we've got our ping speed in milliseconds, our download speed in megabits per second, our upload speed in megabits per second, and our date and our time. So we've got our date and our time. Remember, we separated date time into date and time. You might remember that from the previous lab. So first thing we need to do, remove the unwanted columns, which is basically this column, this unnamed column. So what we can do is we can drop that column, unnamed 0, so this column here, and if we do it in place, then that will then just operate directly on the df compact data frame. So we can run that, and you can see there when we look at the head now, we've basically lost this column because we don't really need it. The next thing we've got is nans. So we might have, as I mentioned previously, we might have nans where for some reason there was a measurement error or there were no measurements or whatever. And these nans can affect the quality of the data. So you've got to think about, well, what are you going to do with them? Do you just replace them with some other value, or do you delete the entire record if one of the data fields has a nan value in it? In this example here, what we're going to do is we're basically going to delete, if there's a nan in any of the fields, so if one of these, say this one here had none in it, then what we would do is we just delete that whole record. But before you do that, what you want to do is you want to find out, well, if I was to delete that whole record, what would be the consequence of deleting that record in terms of the overall data set? So here, what they're going to do, first of all, is they're going to identify using df compact.isNull, they're going to have a look and see, well, how many nuns do we have in the data frame? So this returns a data frame, nuns in which we're calling nuns in data frame. And if you look at it, you can see that the type of it is a Pandas core data frame. So I should run this. So Pandas core data frame is the type. But what it does is it returns true or false, depending on whether there were nuns or not nuns in those positions. So this returns a data frame of true or falses, which matches the data frame that we had before, DF compact. But so isNull, if we call isNull on a particular column or a particular field position within the column, then we can find out whether that is a none or is not a none. So isNull will give us that that ability. So it'll tell us whether it's a none, true or false. So to get an idea of the impact of this, the potential for redundant data or nuns in the overall data set, what they're doing here is they're summing them for every column. And we've got, how many columns we've got? We've got 1, 2, 3, 4, 5 columns. So you can see here's our 5 columns. So nuns in df.sum. And what this does is returns a Pandas series. And a series in Pandas is like a single column of a data frame. So you can think of a data frame as being a whole bunch of series, where each series is one particular column or one of these. So this time would be would represent a series, date would represent a series, download would represent a series, and so forth. Anyway, so this returns an additional series, but in this series we've got ping, download, upload, date, and time. So we've got, and it's got a value for each. So this is how many nuns do we have in the ping? We've got 1 of them. Got 1 nun in the downloads. We've got 7 nuns in the uploads, 7 nuns in the date column, and 7 nuns in the time column. So, and overall, if you were to sum those up, sum them all, you'd find that there's 23 of them. So 23 may or may not be an issue depending on the overall size of the data. I think I need to run this, don't I? Ran that one. I'll run this one. Yep, we've got 23. And we can also do this by calling on df compact, dfcompact.isNull.sum.sum. So what this will do is this will basically sum all of them in the df compact data frame. We'd expect that to be the same value because this data here, nuns total, was derived originally from the df compact. So run this, we also get 23. So in this section here, what they're going to do is they're going to work out what proportion of the overall data frame contains nuns. So without going into the detail of the calculation, it works out the number of nuns divided by the total number of rows times columns, and then does it to 4 decimal places here as a proportion, and just prints it out. So let's have a look. And it says, well, we've got 23 nuns in the overall data frame, which is equal to 0.67% of the measurements. So it's not a lot. Yep. 0.67%. So it's less than 1%. So if we were to delete all of the columns that had nuns in them, it wouldn't really impact a lot on our data. Yep, but it would get rid of those things which could cause problems in our calculations. So what they're going to do here is they're going to call dfcompact.dropNone, and what that will do is it'll remove all of the rows that contain none values. And we're going to call this dfcompact_clean. So this is our clean data frame. So it's got our clean data that doesn't contain nuns. So if I was to I ran that one, didn't I? So I run this one, I run this one, and now we've got our DF compact clean. So you can see here that if we want to look at the size of it, we've got the length of DF compact and the length of DF compact clean. And if I run that, you can see I've got 680 for DF compact and I've got 673 for DF compact clean. So it means that I've lost seven records or 7 rows out of the original raw data compared to the clean data. So I've still got 673 records. So we've got a decent sample size, if you like. Consider this as a sample of the overall data. It's a pretty reasonable sample size to work with. So the next thing we've got to do, if we have a look at the data format or the data types of DF compact D types, and we run this, you can see that we've got our upload, which is a floating point value. So our uploads are floats, but our download and our pings are actually as an object type. They're actually expressed as strings. And our date's an object and our time's an object, which is what you'd expect. But the problem we've got here is that our ping and our download needs to be converted from string into floating point format so that we can do calculations and analysis on it. So we need to convert. So the way that we can do that is using float. Did I run this? I'll just check. Yep. The way we can use this is using float. So if we take a string value and we cast it to a float, that'll give us a float value. So if we run this, you can see here we've got 1056 is our string class, and then if we print our float type, 1056 is our floating value. So this float value, this cast will convert. Now, there's a really good way of doing this across the whole data set, and that is using a lambda function, which we've looked at earlier. So if we look at what's going on here, basically what we're going to do is we're going to clean up the DF compact clean. We're going to, on the ping column and the download column, we're going to apply a lambda function, excuse me, and that lambda function will get applied to every data point in the column. And what we're going to do is the value that we get, the column, the value inside of the column is going to be converted to a float. So the lambda function will be applied to every data point in DF compact clean ping. And what we're going to do is we're going to return a new column, which is DF compact clean ping millisecond float. And we're basically going to do the same thing for the download, so that these string values of ping and download will create new columns called ping millisecond float and download millisecond float, megabits per second float. And these will be in floating point values. So we can run this. And you can see here, if we look at the D types, the data types of the clean data frame, you can see here we've got the original ones. The upload was already a float, but we've created these new ones, ping millisecond float and download megabits per second millisecond float. So basically we can now get rid of these because we've got the floating point values that we can work with. So if we look here, we're going to remove them. So we're going to drop them. We're going to drop ping milliseconds. So we'll drop this one. And we're going to drop download megabits per second. So we're going to drop this one in place. So that'll mean that we'll continue with the same data frame. And the other thing they're going to do is they're going to rename the remaining columns. So they're going to rename these two columns, ping millisecond float, to just ping milliseconds. Same after we drop it, we rename this one to what it was called. And then after we drop this one, we rename this one to what that was called. So we can run that. And if we do a head, just to have a look at what we've got, you can see we've got upload megabits per second, date time, ping milliseconds and download megabits per second. So these are on the end because these were newly created ones that we've renamed. So the next thing they're going to do is to reposition so that the date and the time is at the front and the upload goes to the very end. So you can see here we can re-index, df compact clean re-index, and we can re-index based on this order of columns. So reorder, this is called re-index, but it's basically reordering. And it'll operate on df compact clean. So we can run that and then display it. And you can see that we've got date and time on this side, ping and download there. So date, time, ping and download haven't changed, but this upload has been moved over to this side. So we moved that over to the end, put that one on the end. So the next step is to basically to save that to a new CSV, which we'll call RPI data processed. So we've got df compact clean to CSV, and we'll just save that as a new CSV file, and then create a new one, df clean from df compact clean. So let's I ran this one, didn't I? Yep. Oh, run this one. Yep. And so now we've got our df clean, which we can then run some statistics on. So the next step is to do some statistics, but I might, because I've been talking for 20 minutes, it's probably long enough. I think we might go through that a bit later on.